Hello Math 1093, this is Dr. P with a video on exam question Q10, the one about proving trig identities. Now in this one, you are only required to prove one of the two trig identities, but because I am such a generous guy, I'm going to give proofs of both of them in this video and talk about some strategy that should come into play as we think about how to prove these things. Because a lot of this, really, there's two obstacles that people have when proving these things. One of them is algebra skills, and I'm going to try and make some of that explicit as I talk about these identities. But the other is strategy, just knowing which direction to go in order to move forward. Okay, so let's talk about part A first, because A is a good example of one of my favorite strategies, and that strategy is get things in terms of sine and cosine as much as possible. Okay, so that's what we're going to try and do. We'll try and get this left side in terms of the sine and cosine functions and hope that that gives us something that looks like tangent of t and can be changed back. Now, one thing I want to warn you about is that when you work on these, so this is a warning, it makes it sound like a lot more dangerous than maybe it should be, but only work on one side at a time. Okay, and only write down one side of this at a time for now. If I write down this equation right here, then I'm basically making a naked assertion that that's true. And I don't know that that's true yet. All I can say right now is that cosecant of t times secant of t minus cotangent of t, that's equal to something. I'm going to write down what that's equivalent to. By the way, one other tip, when I work on this, if I'm going to work on one side at a time, I'm usually going to pick the side that has a little more complication to it, because I don't really know how to write tangent of t so that it's more complicated in a useful way. I can rewrite it as sine over cosine, but then I'm kind of stuck. With this, I feel like there's some place to go. So I'm going to try working on the left side because it's a bit more colorful. All right, so I know that cosecant of t, secant of t minus cotangent of t is equivalent to 1 over sine of t times 1 over cosine of t minus, and then cotangent of t is cosine of t over sine of t. That much I know. Okay, and I know that that is equal to, well, let's see, what is there to do here, really? I can certainly take this part here. I'm doing a lot of annotations that probably you shouldn't do in your solutions, just as a way of illustrating things. That's a product of two fractions. That is a product of two fractions. And if I want to multiply two fractions, I just multiply numerators and multiply denominators. Product of the numerators is just 1. The product of the denominators is sine t cosine of t. I mentioned this because I saw some of you, in order to multiply these fractions, you would get a common denominator like sine t cosine t, and then you'd do something to this, and then do something to this to get them both to have that same denominator, and then you'd like combine the numerators. That's not how we multiply fractions. We multiply fractions by just multiplying numerators, multiplying denominators. Alright, so we got 1 over sine t cosine t there, minus, and then I'm just going to leave this b for right now. That's one step. That's a very good productive step there. Okay, so now I really do need to subtract two fractions. So I'm going to mark this off, just make a note that I'm subtracting two fractions. All the stuff in red you don't have to do. It's more annotation for the sake of the video. Okay? So to subtract these two fractions, I need to get a common denominator. For adding and subtracting fractions, I do need to do that step. Alright, so how's that going to go? A common denominator, probably the most convenient thing I could pick would be sine of t times cosine of t, because that would be a multiple of this one. So I can rewrite that second fraction. I'm going to leave the first one alone for now. But I'm going to multiply the numerator and denominator of the second one by cosine of t, because that'll give me an equivalent fraction to what I had before. And now they have a common denominator. So I've got 1 over sine of t cosine of t minus cosine squared of t, because that's cosine times cosine, over sine t cosine of t. And now I can combine. I can combine these because they have the same denominator. So just make a note of that. Combining those with the same denominator gives me what? The denominator is going to be sine of t cosine of t. And I have 1 minus cosine squared of t. Super. That should look familiar. 1 minus cosine squared of t, that is equivalent to sine squared of t and I still have the same denominator, and that's by a Pythagorean identity. Notice I'm writing this in green because this is something I'd like for you to write, that I'm using a Pythagorean identity here. I don't really care about all the other stuff like this is a reciprocal identity, this is a quotient identity, because that's not really official names for anything. But this one, it's such a significant step, it kind of deserves a name. So Pythagorean identity for that. Okay, so what now? Let's see. I think there is something I can cancel, but I want to be really deliberate about this. Okay, you might know how to cancel that right away, in which case, feel free to go ahead. That's fine. But I'm doing this for the benefit of those who might not be sure when I am or am not allowed to cancel things here. So I can cancel these sine of t's here. One factor of sine of t. Because it's a factor of the numerator and denominator. Okay, and I'm being like super pedantic about this, but you don't know how often I get responses to these things where there's like addition up here and there's like sine of t plus cosine of t, and someone's like cancel the sine of t. Well, I can't do that if I have the sum of the two things up here, but if I have a product of two things and one of the factors is sine of t here and one of those is sine of t here, then I can cancel those out. And in fact, I'll just go ahead and make a little canceling motion. Swish, swish. Okay. So now I'm left with, let's put that in green. That's equal to sine of t over cosine of t. Okay, now I've sort of lost track of what I was going for, so let me just look back up here. Hey, wait a minute. Tangent of t is what I wanted, and that looks like tangent of t. So I can write that down and I can say QED or whatever your favorite end of proof symbol is, because that means I have now shown that this thing here, this weird convoluted expression, is equivalent to this other thing, which is equivalent to this other thing, which is equivalent to this, is equivalent to this, and so on and on and on and on. I've shown that all of these things are equivalent to each other, which means this thing, this expression here, is equivalent to this one. That means that these two numbers are equal for any value of t that I might substitute in there. So that means that this thing is proven. Let's mark that as done. So that is proven. All right, great. So that's a proof of that first one. And I just want to take notice of some of the things that we had to think about in order to solve this. So we had to think about how to multiply fractions. We had to think about how to add or subtract fractions, which means we had to get a common denominator. We had to think about when we're allowed to cancel things. So we cancel factors, not add-ins, not differences, not terms. Okay, factors meaning things that are multiplied in the numerator and denominator. Denominator, there we go. Okay, and we had to know our Pythagorean identities pretty well. Those are, I realize I'm going off on like a tangent here, but I want to mention these identities. There we go. Those are, there's three of them. There's sine squared of t plus cosine squared of t is 1. And then there's another one. Let's see, what is the other one? It's 1 plus tangent squared of t equals secant squared of t. And then is there another one? Oh yes, there is one other one. 1 plus cotangent squared of t equals cosecant squared of t. By the way, those two are other things that you might be able to prove. Like you could actually prove those the same way that we proved this problem that we just did here. Okay, anyway, so those are just some things that we have to think about in order to solve these problems. So if you're having trouble with fraction arithmetic, or like fraction algebra, it's not really arithmetic if you've got symbols like t in there and trig functions, but whatever the deal, you've got to know how to manipulate fractions that have algebraic symbols in them. That is part of the game here, and it's something that we assume that you know. All right, anyway, let's go back and let's work on this other one. I'm going to rewrite it a little bit bigger so we have a little bit better access to it. So that second was cosine beta over 1 minus sine of beta, 1 minus sine of beta, plus cosine beta over 1 plus sine of beta, and that's allegedly equal to 2 secant of beta. Okay, well that seems interesting. All right, let's move over here so we have a little bit more room to work. All right, so again, I'm going to start with the gnarlier looking side, which is definitely the left. Now, by the way, I noticed a lot of people on the test sort of added these very glibly by adding the two numerators and adding the two denominators, sorry, Charlie, that will not work. These two things do not have the same denominator, not even close. So we're going to have to get a common denominator in order to add these two fractions. So we got to get a common denominator. Okay, so how are we going to approach that? Well, let's first just write down the thing that we started with. And let's get us a common denominator. So I think a common denominator that works for this is going to be something like probably the product of these would work, right? 1 minus sine of beta times 1 plus sine of beta. I know that's kind of contorted looking, but that's really what it's going to take. We need something that is a multiple of this and is a multiple of this. And the product of those two things is what holds the most promise here. Let's put that in red. Cosine of beta, there we go, times 1 plus sine of beta. I'm going to multiply the denominator also by 1 plus sine of beta. Notice I'm doing all this in parentheses here, because that is one quantity that I'm multiplying by the numerator and denominator. Same with this one. I'm going to multiply the top and bottom by 1 minus sine of beta in order to get that missing factor that I need. So 1 minus sine of beta, 1 plus sine of beta. There we go. Alright, so what now? Well, now I have the same denominator. There it is, ugly though it may be. So I can now combine these two fractions over that denominator. And let's just do that without doing any further operation here. I could do more before doing this, but I think I'm just going to write this down first of all. And now I'm going to do some algebra up top. Alright, so that is equivalent to, okay, I still have in the denominator, let's go ahead and multiply that out, why don't we? That is a, okay, what's the deal with this? This is like x minus y times x plus y, although it's a very complicated x minus y and a complicated x plus y. Alright, so I'm just noticing the structure of this algebraically. That is like x minus y, x plus y, and that's equivalent to x squared minus y squared. Alright, I could also just distribute this out and see that the two middle terms cancel out, but I'm just trying to speed things up a little bit. So that is 1 squared minus sine squared of b. Alright, if you don't believe me, distribute it out and see that it comes out the same. The numerator, on the other hand, is going to be cosine of b plus cosine b sine b plus cosine of b, okay, now I'm distributing the second bit here, minus cosine of b sine of b. And would you look at that? I'm adding cosine of b sine of b, and I'm subtracting it, which means those two terms go away. And so I have cosine of b plus cosine of b, that's beta. See, now I'm doing this thing where I just call beta b over 1 minus sine squared of b. Okay, what do I know about that? Well, the numerator is just 1 cosine of beta plus another cosine of beta. That's 2 cosine of beta. And the denominator, well, that's another Pythagorean identity. That's cosine squared of beta. That's by a Pythagorean identity. Yay. And so now, again, here I have a factor that I can cancel out. I have 2 cosine of beta over cosine beta times cosine beta. And that leaves me with 2 over cosine of beta, because again, I have this factor of cosine of beta. It is a factor of both numerator and denominator, and therefore can be canceled out. And so I'm left with this. Now, is this what I wanted? Wait a minute. I wanted 2 secant of beta, but wait, that is 2 over cosine beta. That's the same as 2 times 1 over cosine beta, and that is 2 secant of beta. Yay, I'm done. Okay, so again, another example of an identity where there was some work to do with adding complicated fractions that did not have the same denominator, at least not at first. Get a common denominator, add them up, combine them, and then use a Pythagorean identity down on the bottom. Both problems had that same feature, and wouldn't you know it, I designed them that way. That was intentional. Both problems require roughly the same type of work. It was mostly a question of whether you preferred to deal with trig functions that were not sines and cosines, or just get right to the point, but have to do a little bit more complicated algebra here. Okay, anyway, that's the end of this video. I hope that illustrates some of the things that I want you to know about proving trig identities. Mostly this is just a matter of following your nose and having a few very good instincts. One of them is we like sines and cosines better than all this other crap. Another one is start with one side and just start manipulating. And the other one is just having this disposition to think really carefully about fraction algebra. If you are not familiar with that stuff, there is a handout I posted online. First of all, I'll remind you that Activity 8 has a bunch more examples of these, and I know that not everybody has completed that, so that's more practice on this. Also, there's a handout online that I called Some Algebraic Ideas That Are Useful or something like that. It's in the main content folder. You might find it helpful to go back and review that in case you are a little bit rusty on the fraction algebra. All right, anyway, that's it. Enough rambling. Stay tuned for more.